Hey robot makers, how you doing? Hope you're having a good day so far. So do you want to learn about HeatSet Inserts, to get that right, and how to use HeatSet Inserts, a press like the one from Naomi Wu? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our keynote. Let me just press that as well. There we go. So the goals of today's session, we're going to learn about Naomi's HeatSet Inset press tool. We're going to learn about what it is. We're going to learn about Naomi Wu. If you don't know who she is already, I would have thought you would do if you watched my channel, but maybe not. We're going to learn how to use it, all the different parts that make it up and so on, who it's for, the target audience, how to get one, the prices, and the cyber night market. It says demo SMARS in action. No, it's demo heat press in action. And if you're here for the live stream, we'll also have a bit of a mailbox and a Q&A as well. So let's get straight to it, shall we? So yes, who is Naomi Wu? So Naomi is a technology and DIY content creator based in China, in the Shenzhen area. She has a nickname of Sexy Cyborg, and some notable achievements from Naomi. She's pioneered visual. Let me start that again. Pioneered visibility for female makers in the tech community. It says especially in China. I would say globally. She's definitely one of my top female makers that I look up to, and she's definitely the largest YouTuber in China. So you'll probably see her content going back quite a long way. She's made a lot of different builds, quite a few robots as well, which I quite like. There was one that she made which was like a robotic barkeeper. That was pretty cool. She's known for blending technology with fashion, wearable tech like LED shoes, underlit skirts and so on, and she's also an advocate for open source hardware and software. So one of the things we're going to be looking at today is some hardware, and she's recognised for a hands-on review of Shenzhen's local electronics markets and maker spaces as well. So just a general all-round awesome human being. So this is the tool that she has sent me to have a look at, which is the HeatSet press. I think that's what you call it, HeatSet Inset tool, and it's designed to basically put these small brass HeatSet insets. We're going to have a look at these in detail. These little brass things with little knurlings on them. They have a little thread inside there, and these are, instead of using like a captive nut to make two parts stick together. So if you want to have like a quality finish on some of your parts, then this is one way to go about that. So this particular press has got a really quality hot end. So it's essentially like a hot iron, like a soldering iron on a press that you can move up and down, so that you can push this into the part at exactly 90-degree angle. So you're not doing it sort of skew-if, because once you start putting heat to these HeatSet insets, they will start to move around as they melt the plastic. So if you don't have it at exactly 90 degrees, you'll get all sort of wonky fittings and so on. So it's height adjustable as well, so there's a nice little screw thing you can screw and move it around sort of height wise, and you can also have these little bars as well that you can move up and down so you don't get burnt, which is what will happen if you try doing this with a soldering iron. And it comes with a very sturdy frame. It's very robust in general, very well put together, and it's made, as you can see there, a sort of aluminium and 20 by 20 extruded bar, that kind of thing. Comes with a power supply, an adjustable temperature thermistor, I guess, for the heat hot end, and also all the other bits and pieces there with some replacement parts as well. We'll have a look at those too. So what problems is this trying to solve then? So this is for 3D printed threads. So if you have a part such as, I get one of my burger bots here, for example, I've got these little motors that I want to connect. There's a motor which you can see there is, if I just cover up my face and hold that there, you can see I've got a little motor and I've got a little 3D printed holder part, and it's got two little sort of wing nuts on there, and the idea is that you can put a captive nut into this and then screw this onto something like this BurgerBot base here, so that you can attach a wheel to it. So that would actually be for the other orientation. So you can put this on here and it's got like the little wheel thing on there. So the way that I can connect these two parts together is basically just using a captive nut. So a nut on one side, a screw hole, and then it squeezes the two together. So one of the challenges there is If you don't have the size of the hole correct, then the screw will move around and you won't get a nice join there. Or if it's too tight, you try and squash it together, you can end up cracking the entire lug nut there. So that's not really what you want to do. And I've had this happen on quite a few of these burger bots where I've got these kind of up and down sort of lug nuts. If I just show you that there. So there's holes for those captive nuts, little hex nuts, and the top and the bottom of this attach through using some holes and some M3 screws I think I used for this one. So one of the problems with trying to use 3D printed threads, you can tap threads. I've got a tapping tool just on my workbench over there, and essentially you can basically get a piece of a hole with no thread in it, put this brass thing in and it'll create a thread. But threads on 3D printed parts don't tend to last very long. You might get 1 or 2 goes at it before you've threaded the thing and you've basically heated the plastic up internally and just threaded it and it's just loose. So if you want something that you can open and close and take off, take on many different times, you want something that's a metal based threaded part. So this will solve that problem by actually giving you a threaded part that's made of brass, so you can screw that screw in many different times, and it's connected solidly to the 3D printed part. The other thing you can do with the threads, if you over tighten something, you'll essentially just strip the internal thread of the 3D printed part, and again these brass ones will get around that issue. You're unlikely to over tighten it to that extent on a 3D printed part. So the HeatSet insets come as little nuts. I've got a whole bag of different size ones here. So these ones are, I think, M5 ones, I think. So you can just see in there, there's like little brass things. We'll have a look at one closer up in a second. You can also get to even larger sizes, so they've got a slightly larger bag of them there. And they're very cheap. I think these are these M6 ones. These are absolutely huge. So you can see these ones here as well. So they're sort of getting larger in size. But you can get very small ones too. So they're very durable. So very strong, very durable, and perfect for, again, putting 2 different 3D printed parts together with a really solid connection. And the HeatSet insets are inserted into a 3D printed part. Sorry, Alex just disappeared then. And they use heat to melt the 3D printed surround ever so slightly, just enough that the 3D printed filament will come against this knurling on the HeatSet inset, and it will then make a solid join as it cools back down. It basically forms around it and it doesn't go anywhere. You can't twist it or anything. So that knurling, these funny little diagonal stripes around the edge, form a solid bond with the plastic that they're set into. It's quite difficult to explain that. I think it's more intuitive when you see it. You're like, I get it. So this is one of these HeatSet inserts. So it's brass, or other types of metal are available as well. And you can see there they've got an internal thread, which is where you put the normal bolt in, and on the outside they've got these knurling patterns, and they've got them in opposite directions so that the plastic, when it sticks to it, it doesn't matter which way you turn the screw on there, it's going to hold it solidly in place. They're very cheap to purchase these in sort of large quantities, and the heat being applied from the hot end basically just touches the part. We can see that on the next slide. So this is how we actually use it. We get our, I've got some I've made earlier. Let me just get this little part here. So I've got these little test 3D printed parts. So essentially just got a couple of holes in it, and we get our little heat set and we put that inside like so. So we basically just put it slightly inside the part. I need to see if I can do that without dropping it. It's quite hard to do. So if I do that, and you can see that, so it's just sort of sat slightly inside, and that's because there's a little piece just above where the knurling starts. So you put that into the hole, and the hole is the same size as the screw that you would intend to use. So if this is like an M5, the hole I think is an M5 sized hole as well. And they go from like M2 and 1.2, I did just drop something then, between M1.2 to I think all the way up to M6, something like that. And there is different size pieces that you get with this particular heat press, different sized nozzles, hot ends, so you can interchange them as needed. So you can see there, you put that there, then the hot end comes in and transfers the heat into the little HeatSet Insert, and then that then pushes very gently with very, very little force, to be honest, into the 3D printed part. At that point, it will then lock in place when you remove the heat. It'll sort of seal back up. So the ideal kind of settings there will be about 300 degrees C, and that seems to be more than enough for about 15 seconds. It's more than enough to heat the plastic. So what does Shemi there says, can you drop your open box of insets, please, just for laugh? That might happen by accident. These ones luckily are all sealed, so that's not going to happen there. But I've got a bag that's open. I did just drop one actually, but I've got a whole load of them, so it's fine. So yeah, it's just a transfer of heat, melts the plastic, and then it's securely in place. Very, very simple. So the accessories box, I've got mine here. It looks like a little pencil case. And in here, as well as some instructions, you've got things like like an Allen key for adjusting the press, and you've also got in here, let me find, different sizes of, see these little pieces here, different sizes of hot end, the sort of nib that goes on the very end there. So if I can get that there, you can just about see that's a nice brass piece there. Nice solid. So there's a couple of different sizes depending on what size insets that you're using, and there's also, if I can get this out without dropping it, here we go. So this is it's like the temperature probe and the thing that actually transfers the heat from the heating element, which goes in the very top. It's kind of like a pen. Looks like a pen, but it's essentially like a temperature controlled soldering iron. So you can see there we've got a few different things. We've got the heating elements for 1.4, 1.6, 2.5. We have another heating element for the 3, 4, 5 and 6. And M stands for machine screws, if you've come across them before. And then we've got the inset tips for the 3, 4, 5, 6. And they're the heat set nuts. And then we've also got the 1.4, 1.6, M2 and M2.5 heat set nuts as well. And there's also a little bag of accessories, which is just a whole bag of little different sizes of things that you can put in there. So you get quite a few to play with to begin with. Okay, so you can also buy larger boxes of these as well. They're very, very cheap to buy online, and you can get one of these kind of, this is like a 370 piece set from Amazon, I guess. And they're designed to be used inset once, and then you use them as many times as you like to sort of screw and unscrew. They don't tend to be, you don't take them out of the 3D printed part once they're sort of solidly in there. They're very, very low cost, like I said, with a very high quality thread in there. So the how to use it, we've got the hot end power supply there. We're going to set this to 300. We're going to do this in a minute on our live demo. Hopefully this all goes well. We switch it to 300 degrees. I think it comes on at about 200. I've tried a few different temperatures. 300 does seem to be the best temperature, even though if you think PLA melts at about 200 to 220 degrees, 300 is the heat going to the hot end nib, and that's to transfer the brass, and then from the brass to melt the plastic. So the plastic isn't getting like the full 300. And we're only doing this for a very short amount of time, up to about 15 seconds. So we wait for that temperature to be reached. It has like a little dial, a little gauge on there that tells you what the current temperature is. And once it's got to there, we can then start using it. We position the part underneath the nib. So I've got a camera set up so we can see how all this works. And then we lower down. There's like a little T-bar that you can lower down, and that will make the hot end make contact with the brass inset piece. Once we've done that and it's melted to the correct depth, we can then just remove the thing and let it cool down, and then it's solid. So I've tested out a few pieces already. So this one, this is my little test rig. What I did on this one is I tested out a 5mm, a 5.1mm and a 4.9mm to see if there is differences in the tolerances and if that makes a difference. And one of the things I found is if you make the hole too small, and when you push the part into it, you'll get some of the filament being pushed to the very bottom. So if I show you the bottom of this part, you can see the one that's on the very right there has kind of a piece of red plastic in the hole, and that's because that was the 4.9 hole, so it wasn't quite large enough to sort of seamlessly go in there. But these are solidly in place. I think these are 8mm ones, so that the depth of them is 8mm, but they're nice and flush and they're not going anywhere. So I'm really pleased with how that works. Okay, so who is this for? So this piece of kit isn't for everyone, but it is for people who are small industrial users looking to lower the mistakes being made by putting these in manually. Like I said, if you don't do this exactly 90 degrees to the actual part that it's going into, if it's ever so slightly off, you'll make a real dog's dinner of that and you won't end up with a quality finish. People who do want a quality finish with their 3D printed parts, putting them together. So for example, on my burger bot, I like things to be nice and flush, and using captive nuts doesn't always get where I need to be with that. So luckily this will solve that particular problem. And it's also for 3D printing hobbyists looking for reliable connections between two 3D printed parts. Very easy to sort of manufacture this. You essentially just put a hole in there, which is the same size as the piece that you want. So price wise, these are $250, and you can get these from Naomi Woo's Cyber Night Markets shop, which is online. You go to cybernightmarket.com. You'll find them on there, along with quite a few other very specifically hand curated parts that are on there. So check out that. So if you like what I do and you want me to make more of these kinds of videos, please drop a like on this video. Drop me a comment, let me know if you've heard of Naomi, and say hi. If you have, you can at Sexy Cyborg, I think at Real Sexy Cyborg, and Naomi will get that notification through. And you can also subscribe to the channel as well. It means a lot to me if you do subscribe. We just passed the 20,000 subscriber milestone. I think it was the week last week, so really pleased about that. So let's get to the 100,000 mark so I can get the plaque. That's my next big goal. Okay. I do go live every single Sunday as well. I didn't go live last Sunday because I'm working on a super secret project that you'll learn all about shortly, I guess. But yes, currently we're live now. So every single Sunday, 7 o'clock UK local time, which is currently British summer time. I think that ends at the end of October, about a month from now. And yeah, you can hang out with me and talk after the main show. Right, let's do this, shall we? So this is the demo. What I'm going to do, I'm going to go to the overhead camera first, so you can sort of see the top-down view of what's going on. If I press this button here, you can kind of get the whole studio. So you can see on this little window just there. You can see I've got this little camera. This little camera is this view here, which is looking at the heat set. So at the moment it's not switched on. I don't get burned. Just behind that is the little power supply where I can set the temperature. I can also move this about if we need to. You can just see there we've got the little temperature screen, and we've also got the you can see here, this is where you sort of raise and lower the part. So if I pull this up, you can see it goes up and down. Now interestingly, Naomi was saying that she tried lots of different springs and things to give this so it returns to the right place, and so that it applies the right pressure kind of automatically in a downward way. And the way that she found was best was actually rubber bands, because they're very cheap. You can apply 1 band, 2 bands, as many as you need to get to the right strength. So it's quite calibratable in that way. The other thing at the very top of the device over here, you can probably just about see that if I just move this forward. That's BurgerBot falling off there. There's a little wheel you can turn, and this will lower or raise the hot end there. So if you look, what I want to do is get that so that it's clear. So I'm just going to make it go higher, and it needs to be quite high so that it can make contact with the piece. So if I drop a piece into here, for example, I want it to be making contact with that piece like so. I actually want it to be the full depth. So if I just put this down to here before we start doing any heat, that should be sufficient. Right, so I can move that out the way there. And what I'll do, I'll go to this particular view, which is the webcam view. So hopefully you can still hear me. Let me know in the comments if you can still hear me okay. It also gives me a chance to pick this up off the floor. Right, so what we're going to do, we're going to power this on first of all. So if I just move this back ever so slightly, you can see that the power supply is just here. So the first thing I'm going to do is just switch that on, and that's going to first of all just go to about so it's gone to 300 degrees, which is actually what we want it to be. I don't know if you can just about see that there. It says 260, 230, 240, there we go, 250. So it's heating up quite quickly. Let's put that camera back there. And what I'm going to be using is these little T-bars to lower and raise the hot end. So what I need to do, I'm going to be using this red one to put them in place. So these have got some nice 5mm holes already printed into them, and if I put the little heat set into it, it won't push in so far. It's the little knurling sort of stops it from going any further in so far. The holes go all the way through to the bottom as well. So what I'll be doing is I'll be raising this, putting this underneath. Well, now it's at 300, we can do that. So I'm going to raise this up. I'm going to push this down and basically just under its own weight. I'm just going to let it do that for a second. We need it to be about, what is about 15 seconds. If I sort of gently start moving that down now, we'll see if that's going into place. So that's now pushing ever so slightly in. It's transferring the heat. I can see it going down. And then it's now about flush. There we go. So if I now move this up, move this out of the way, you can now see that we've got the part where we want it to be. And we can look on the other side. It's nice and tidy. There's no mess. Let's go to the main host camera and have a look at this a bit better. So if I hold this up here, so that's the underside. Look how nice and smooth that is. And if you look on the top side, you can see there that that's flush with the top as well. And if I touch that, it's probably still quite hot. It's not burning hot, but it's still quite hot to touch there. So we can do another couple of them just to show you how that works. Again, so let's get another one. Let's get another two lined up. Make sure these are the right size. Yep, they look it. So if I do another one there, let me go to the other camera so you can see, and let's go over here. There we go. So you can see that they, if I get this to that side there, you can see they're sort of sat at a nice 90-degree angle already. I'm just going to lift up this press. It'll jump back down with the elastic bands, are basically just pulling it down. So all I need to do is just lift it up a little bit, put it into place, just let it transfer some heat for a second, and then let's just gently push this into place. I don't need to apply very much force. You can see I'm just using my my finger there. It's very, very little. We can now do the next one. So very, very little force. It just goes in like a hot knife through butter. There we go. That's all the way through. Again, let's go back to the main camera, and you can now look and see we've now got three. And it's very, very quick to do and very nice and tidy. There's absolutely no mess. And that means now that we can get this part, we can get like another part that we've made, and we can screw them together, and they'll be absolutely tight because they've got those nice brass insets inside there. Try and get that into focus there. So I've got two of them. So yes, it's as simple as that. And once we've finished using it, if we go back, let's go back to that view there for a second. Once we've finished using it, we can just power that off just by flicking the switch on there. We just need to make sure we don't touch that for the next 5 minutes or so, because that's going to be very, very hot. You could also get a regular hex screw, like a little 6-sided screw, and just apply some heat using the hot end into that and push them into place on a captive nut, like I have for these Burgerbot sort of fascias. As you can see, they've got these little holes for the captive nuts to go into. But a better idea is to redesign these so that they use the captive nuts in the first place, or the HeatSet insets in the first place. So yeah, so Adam's asking a question: if the hole is not printed properly, the heatset gets filled with plastic. So it depends on the size of the hole. So what I did before the show, like I said, let me get this one on screen again. I created 3 different sizes of holes. I actually did, there's the one, if I hold it this way round, that makes more sense to me. So the one on the very left is exactly 5mm. The one in the middle, it's got a tiny one single dot above it. That one is 5.1, so slightly larger, and then the one which is on the very end, which has 2 dots above it, is 4.9mm. So that one has a bit of extra material around it that has to get pushed out the way when you push the heat press into it. And what that means is you get that little piece at the very back there. If I just show you that, there's a little piece on the right hand side. If I hold it the right way around, you can see there that it's got a piece of 3D printed filament kind of melted and pushed through, so that when we look through it, we don't get a nice clear hole there. We'd have to push something through there to get rid of that. So the clue, the clue there, the best tip is, the best advice is to use the hole to be the exact size. Don't allow any over or under tolerances for that. So I did measure these with my very cheap, let me just grab these digital calipers. I'll tell you a very short story about that as well. We went to Hobbycraft, which is a craft store in the UK. They sell all kinds of hobby materials, and I saw that they had this exact digital caliper. You could even see it had the same sort of branding on there, carbon fiber composites and so on. So I bought this on Temu for 98p plus shipping, which wasn't very expensive. They were selling this for £22 in Hobbycraft, so it does pay to shop around for your part. So if I now get this and I look at the size of that, you can see if I get this to there we go, 4.9mm is what it's reading that as. So it's designed to be 5, so they've already built in a bit of tolerance, so it's got 0.1 tolerance on the part already. So we want that to be a 5mm hole, and that will work perfectly. Okay, and you can see how quickly it is. So if you're manufacturing lots of different parts, say you're making burger bats en masse, for example, you could do this quite quickly. It doesn't take very long. It wasn't even 15 seconds to machine these into place. So I can see that that's cooling down now. So the way that this it has this sort of probe on the top there that we can unplug. So you can just see there on the cameras, that's what it looks like, and you basically push that in. That's both the power and the temperature sensor going back to the power supply. And the power supply is just like a kettle lead. That's probably the wrong term for it, but yeah, that's it. And we can use this little dial to sort of turn, raise and lower the heat hot end. And once we've used it, we can just put it out the way. I usually just have it at the back of the studio over there when it's not being used. So very, very simple to sort of operate. Okay, so let's get back to our slides and see what else we have. So yes, if you've not found Kev's Robots learning platform, you want to check that out. There's all kinds of courses on there, and I'm adding to this all the time. So if you go over to kevsrobots.com/learn, you'll find the learning platform, and there's all kinds of free courses. No sign up, no kind of put your email address in, straight into the course, and you can learn about Python, about robotics, all kinds of stuff on there. And we have merch. We have the Kev's Robot. I've got another one just here. I've got the two hats. People didn't like my red hat for some reason in the US I don't know about, but I've got my black hat on instead because I'm a black hat hacker. We've also got the mugs as well. I don't know if you've not got your mug, have you, there today? We use them quite a lot. We've got a BurgerBot mug, and we've also got the Kev's Robot branded mug as well as the notebooks. So yeah, check that out. We also have a Discord server. If you've not checked out our Discord server, we've got a really vibrant group of people on there. Laurie's really sweet. When everybody joins, Laurie always sort of says hi to them. So thank you, Laurie, for doing that. It really makes it sort of nice place, which is what I want it to be there. So if you have any questions, don't message me in the YouTube chat about that necessarily. If you want a really detailed answer, go to Discord and you'll probably get a quicker response from the people over there. And I'm all over social media as well. So I'm Kevin McAleer at threads.net. I'm Kevin McAleer 6 on TikTok. On Instagram, I'm just Kevin McAleer. On X, I'm at Kev's Mac. I'm not sure how long X is going to be widely used. It used to be the town hall, didn't it, where people had conversations about all kinds of things. But if Elon's to be believed, he's going to put up a paywall, so everyone has to pay to use it. I imagine it's no longer going to be the town hall so much as like a private club that you have to pay to be a member. So it'll be interesting to see what that does to the rest of the other social medias. I'm also on Mastodon Social, so Kev's Mac at Mastodon Social, and also quite recently I'm at Kev's Mac at Blue Sky as well, so you can find me on Blue Sky if you want to try that out too. Okay, so if you want to help support the show, there's a couple of different ways you can do that. So somebody just did this just before the show started as well. So thank you for the super thanks I think they gave me. You can do the super thanks just underneath the main player window. There's like a little thanks button. You can press that. If you're doing the if you're on the live stream now, you can do a super chat as well. I'll make sure all that's switched on, which it is. There we go. And oops, what's that one? Is that the I like that widget 404 not found? That's the buy me a coffee widget. I'll have to look at why that's not working. And you can also join the YouTube membership program as well. So if there's a little join button. If you just want to get your name in the credits, though, you can just go to kevsrobots.com/coffee. I've got all the shortcuts on Kev's Robots there. Okay, what else we have? I think we have one more slide there, which is our supporters, of course. So why has it gone to that camera? Let me change that camera back to me. I don't know why I did that. So yes, we have quite a few supporters to shout out. We've got Eric Hart, Steve Gale, and somebody who wanted to remain nameless. They bought me a coffee quite recently. We have Adam Sargent, who's Haunted Howarth. Hey Adam, how you doing? We have DN Corty. We've got Marlene Brent, who's on the live stream now. We've got John Rank, we've got Tom Shemi, and Steve Phillips, who are also, I think, on the live stream. And members on YouTube, we have Chris, who joined quite recently. We've got Cassie. I'm not sure, is Cassie on the live stream as well? I don't know if I've seen her name just yet. Say hi if you are. We've got Tinkering Rocks, we've got JDM, Johnny Bates, Bill Hoy, Oxrad39, Javi Gold, Hans from Cheerlights, Michael, and we have, of course, Tom as well. Thank you so much for subscribing, guys. Okay, so that's everything I've got for you on the main part of the show. So I'm just going to press my little flag button there. So if you're watching this on replay, I'll say thank you so much for watching, and I shall see you next time.